We keep saying monsoon is a heat source, so obviously we have to come back to PV, right? The potential vorticity. If you remember from chapter 9, it's defined as minus G eta theta d theta dp, where this is the vertical structure, and that's the absolute vorticity zeta theta plus F. So this is the isentropic potential vorticity, and the idea was to look at vorticity distributions on an upper level isentrope, and the lower level isentropes obviously intersect the tall features like the Himalayas and the Tibetan Plateau, which you can clearly see here. So this is showing January climatology and July climatology going from the southern hemisphere into the northern subtropics. So you see the negative sign of the isentropic vorticity, potential vorticity here, and positive here, and you see the impact of the heating and the vorticity balance that is needed to go with the precipitation and the circulation, right? We can look at this much better on the 370K PV climatology for DJF and JJA, and we see the features we are already quite familiar with. We are have the easterlies and the westerly duct, and seasonally we have the upper tropospheric trough, and we also have the PV minimum here in the so-called Asian monsoon gyre that's going to set up in the JJA. So the high PV from the higher latitudes is advected into the lower latitudes at the westerly duct and the trough, as we know, and there are various other features, of course the Atlantic version of the westerly duct and the flow around the monsoon gyre during the summer season, extending all the way across over to the prime meridian or the Greenwich meridian. And we know that there is also the eddy fluxes from the tropics to the higher latitudes that we are not going to focus on here. So the large scale structure of the monsoon in terms of PV in the upper atmosphere becomes quite clear here in terms of how it affects the PV, which is a critical variable that we used not only for invertibility in some situations, in the especially in the extratropics, but also because of the tropical extratropical connections. So obviously there are ideas that this subtropical heating also produces PV perturbations that then penetrate into the tropics, which is not very similar, very dissimilar from what happens at the jet exit region, except that this is at in the subtropics, where this is in the mid latitudes, right? This corresponds to the large-scale arguments we had made in terms of the heating in the deep tropics generating signals emanating to higher latitudes, and the eddy fluxes giving us the mean Hadley cell, and the eddy fluxes giving us the strong westerly jet, and the recursive or recurrent breaking Rossby wave signals that were propagating PV into the lower atmosphere, lower latitudes. Oops, why did it keep doing that? Okay, so then the westward advection of the PV in the lower latitudes in the easterlies, and then back onto excuse me, the extratropics, right? So this tropical extratropical exchange we had argued was very different, is very important. My words are failing me today. We can also learn a little bit more by looking at the annual cycle of the PV. So this is the cycle of the 370 Kelvin PV field for April, May, and June. And during the early part of the year, as spring is arriving, you still have the trough and the communication from the higher latitudes into the tropics, and you see PV minima near the in the tropics, and the monsoon is not set up yet. By May, you begin to have the land-ocean contrast. You don't have the absolute vorticity lines crossing here, but you see some wavy patterns on this side in the Pacific and Atlantic side. And you see the strong invasion of the PV from the subtropics into the tropics, beginning to create this PV minimum associated with the Asian monsoon gyre, which becomes much more clear in June. And you can see this clear advection southwestward into the low latitudes, which is then going to trek across into the Greenwich Meridian Atlantic, as we saw here. So you can see this very clearly here, circulating around the Asian monsoon gyre. Okay, so this is the large-scale macro structure of the monsoon, and the main point to remember is that we will see later on a little bit about the heating of the Tibetan Plateau and the PV minima and so on, and the focus on all India monsoon rainfall can make you feel like everything is happening here in terms of the ITCZ, its split, tropical convergence zone over land, Bay of Bengal, the mesos, monsoon depressions, and so on. But actually there is a global scale circulation involved. Some of it we had talked in the context of the monsoon desert hypothesis, where we said this heating and the Rossby waves provide the additional subsidence that is needed to explain the heat lows and even the subtropical highs over the ocean. Okay, so it is a large-scale system, and the macro structure is best understood in terms of the PV distribution and the associated tropical, extratropical exchanges. Okay, so we'll leave it there and come back to other aspects of the monsoon dynamics in the next podcast. Essentially, we are repeating some of the ideas we have built up in terms of the PV exchange and the monsoon buildup, and we will add more details of the monsoon in this context, and always keeping in mind that it's a very strong seasonal feature. In that sense, it is also a recursive perturbation to the system, like we talked about the breaking Rossby waves from the mid-latitudes and the convection in the deep tropics that was pumping eddies to the extratropics and back from the extratropics into the tropics.